This is paper 2, question 12. Apologies that this solution is already written out. I'm just going to go through it because the video didn't record properly first time. So, we have an equation here. Sin x add cos y equals 0.5. And we've given some ranges for x and y. Point P lies on C. The tangent to C at P is parallel to the x-axis. So that means it's horizontal, therefore the gradient is 0. So any time when we see a question that's talking about tangents and gradients, that's telling us that we need to start off by differentiating. So we have our function sin x add cos y is 0.5. Sin x differentiates to cos x. So we can pop that straight in. Cos y differentiates to negative sin y. But because this is a function of y, not a function of x, we need to pop dy dx on the end to say we have differentiated this function of y with respect to x. And this is equal to 0.5. When we differentiate that, we get 0. This is implicit differentiation, if you want to look it up in the book. I've rearranged this. So I've just added sin y dy dx to both sides to make it positive. We want the gradient functions. We want dy dx on its own. So I've divided here by sin y. And this is the gradient function for this curve. We've already said we want the gradient to be equal to 0. So my next step was to set the gradient function equal to 0. And this is the equation we need to solve to find those coordinates where the gradient of the original function is equal to 0. The solutions to this will be cos x is 0, because if our numerator is 0, 0 divided by anything is 0, except we can't divide it by 0. So sin y is not allowed to be equal to 0. Now, fortunately, that doesn't actually affect us for the rest of the question, but it's worth noting at this stage because there might be a similar question where it does affect us. We can solve the equation cos x is 0 to get x is pi over 2. Now, thinking about the range of values here for x, this is restricted between positive pi over 2 inclusive and 3 pi over 2 not inclusive, so it's excluding that point. Now, those two would have been our first two solutions, but we can't include that one. We can't extend beyond either of those two, so pi over 2 is the only solution for x. We now need to substitute this value of x that we have back into the original function to find the corresponding y coordinates. So I've substituted sine of pi over 2, so x, that's equal to 1, add cos y is 0.5. Subtract the 1 from both sides to get cos y is negative 0.5. And then to solve that equation, you can pop it in your calculator, use your exact value triangles. That will give you one of these two solutions, depending which calculator you put it in. Make sure your calculator is in radians. When you've got one solution, use the symmetries of the sine graph to find the other solution. So our sine graph looks like that. Cos graph. Apologies, so that's negative 0.5. So there's one solution, and here is the corresponding solution on the other side, and both of those are within the range of y. So that goes between negative pi and positive pi. Both of those are between those. So we have one x coordinate, but two different y coordinates, and they're the two solutions that we're after.